Okay, this video is going to review the problems on your notes from determination of microscope, field of view, how to measure from a microscope. So this is on page 3 of this packet. You should read through microscope magnification on the second page. And then go to the third page. There are some practice exercises. We have some great background music to help you focus on your problems. So we have, the first problem says, what is the total magnification of a microscope with a 15x ocular, which is the eyepiece, and a 40x objective? So all we're going to do for that is take 15x times 40x, and we get 600x. So that's our power. The next problem down says a student determines that the field of view again is basically what you see under the microscope from here to here. That's your field of view, how much you can see when you look into the microscope. So if we measure this with a ruler on low power, we can calculate the distance across for the field of view on a higher power. So a student determines that with a 10x ocular and a 4x objective, the field of view is 2.5 millimeters. So this would be under the, if we multiply those together, we get 40x. So we know what that under 40x, the field of view across is 2.5 millimeters because they gave that to us. So now they're asking, what is the diameter with the same ocular and a 10x objective? Same ocular, 10x, times 10x for our objective lens. If we multiply those together, we get 100x. So now that we have those two, we have 40x, we have 100x. If we go back to your calculations from your notes, it'll tell you take the high power field of view over the low power field of view, the low power magnification over the high power magnification. So all we're going to do is do that same thing with the numbers that we just got. We have a low power magnification of 40x, and we're going to divide that, so we're looking at this right here, and the high power magnification of 100x. The field of view, we only have it for the low power magnification, and that was given to us at 2.5 millimeters. We don't know the high power field of view, so we're going to calculate that. Excuse me. And all we have to do is cross multiply to get the 2.5 on this side. So 40x divided by 100x times 2.5 millimeters equals the high power field of view. This is going to equal, take our handy dandy calculator, 40 divided by 100 times 2.5, and we get 1. So 1.0 millimeters is the field of view under 100x, or the high power. And then it asks you one more question. So our answers here so far are, we have 600x. Here we have 1 millimeter. That's the answer we just got. This question asks us, what is the diameter of the field of view if, with the same problem, you have a 10x ocular and a 40x objective? All we're going to do is substitute this. We're going to use that same problem, but instead of 100 here, we're going to use 400. So we're going to do 40x over 400 Again, we have the high power field of view times 2.5 millimeters equals, and we'll use our handy dandy calculator, 40 divided by 400 times 2.5, we get 0.25 millimeters. And that's going to be the field of view for our 400x. So all it's telling you is that we already know that under 40x we can see 2.5 millimeters across. So that's at 40x. At 100x we can only see 1 millimeter across. And at 400x we can only see 0.25 millimeters across. So by using those calculations we can figure out if an object might be this big in that field of view, but in this field of view it's going to look this big, and in this field of view it might be much bigger. So we're going to see a very small portion of it. So we had 1, and then this answer is going to be 0.25. And then at the bottom problem here, they ask you if the diameter of the field of view under the microscope is 2.5 for this, what are the approximate dimensions of the amoeba? So we have 1 millimeter. They're giving you that line. They're giving you a line there for millimeters. We can kind of estimate with our pen. That's 1 millimeter. So from here to the bottom of the amoeba, let's say 1.3 millimeters tall. And then for width, we already measured this about 1 millimeter, so we can go from there to there. It's about 2 millimeters. So it's about 2 millimeters wide. So that would be the answer to number 4. If we go to the next page, all it's asking is to do the same thing. This is 1 millimeter here, 1 millimeter here. Estimate the length of the organism in the field of view in the illustration below. So again, if I use my pen as a reference for 1 millimeter, and I come over here, about what's the length of that? It's about half of the measurement on my pen. So we could say this organism is 0.5 millimeters. So that would be the answer to number 5. And then finally, it asks you to find the dimensions for these organisms. We know this is 1 millimeter. We can come over here and look. It's larger than 0.5, but it's smaller than 1. So we can see about 0.6 or 0.7 millimeters. We can estimate this one at. So let's say 0.7 millimeters. You shouldn't say more than 1. You shouldn't say less than a half. This one, we already know this is 1 millimeter. So this is about, again, it's probably about 0.8 millimeters for C. And finally, this little one, we have to kind of estimate how many can we fit in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can fit about 16 in there. That means this little guy here is about 1/16 of 1 millimeter. So it's about 1/16 times 1 millimeter. This is all estimation. So 1 divided by 16 is about 0.06 millimeters for B. And that should be it. If you have any questions, let me know. Have a good day. Be good. Don't smoke. Don't do drugs. Look both ways when you cross the street. And don't ever talk to strangers.